Welcome back, everyone, to another fascinating journey into innovation and discovery. Today, we explore how manufacturing in space could transform industries, reduce costs, and unlock extraordinary possibilities beyond Earth. From orbital factories to advanced materials, you will discover why this emerging frontier matters for humanity's future. Stay with us until the end, and please remember to subscribe for more amazing videos every week on groundbreaking science, technology, and future innovations that inspire, inform, and expand your imagination. Please subscribe today. Number 5. Microgravity. Microgravity manufacturing takes advantage of the unique environment found in orbit, where gravity has only a minimal influence on materials during production. Without strong gravitational forces, liquids, metals, and crystals behave differently, allowing scientists to create products with fewer imperfections than similar items made on Earth. This environment supports experiments involving advanced semiconductors, optical fibers, pharmaceuticals, and specialized alloys. Researchers can carefully observe how materials solidify, mix, and grow without sedimentation or convection, affecting results. Such conditions often produce exceptionally pure crystals that improve scientific research and commercial technologies. Medical companies are especially interested because certain proteins form more accurately in space, helping researchers understand diseases and design better treatments. Although manufacturing beyond Earth remains expensive, technological progress continues reducing launch costs and improving orbital facilities. As more private companies enter the space industry, microgravity production could become increasingly practical for high-value products requiring exceptional precision. Continued innovation may eventually transform orbiting laboratories into efficient manufacturing centers, supporting both scientific discovery and commercial development worldwide successfully. Number 4. Factories. Orbital factories represent manufacturing facilities positioned in space instead of on Earth's surface. These stations are designed to assemble satellites, spacecraft components, scientific instruments, and specialized materials without repeatedly launching complete structures from the ground. Building equipment directly in orbit reduces the need for large rockets carrying fully assembled payloads, potentially lowering overall mission costs while increasing flexibility. Robots, automated systems, and remote operators can work together to construct large frameworks impossible to fit inside traditional launch vehicles. Future factories may produce replacement parts using recycled spacecraft materials or raw resources delivered from the moon and asteroids. Continuous production in orbit would support satellite maintenance, communication networks, scientific exploration, and deep space missions requiring reliable infrastructure. Engineers are developing advanced robotic technologies capable of performing precise assembly tasks with minimal human supervision. As launch prices continue decreasing and reusable spacecraft become increasingly common, orbital factories could expand into permanent industrial centers. These facilities may eventually manufacture enormous space telescopes, solar power stations, and exploration vehicles supporting humanity's growing activities beyond Earth for generations ahead. Number 3. Moon. The Moon offers valuable opportunities for manufacturing because it contains useful natural resources that can reduce dependence on supplies launched from Earth. Lunar soil, called regolith, contains minerals, metals, and oxygen that may support construction, life support systems, and industrial processes. Instead of transporting every building material through space, future missions could process local resources into bricks, landing pads, protective shelters, and structural components. Advanced technologies including three-dimensional printing may transform lunar materials into durable infrastructure for research bases and long-term settlements. Water ice discovered in permanently shadowed craters could provide drinking water, breathable oxygen, and hydrogen fuel for spacecraft. Using resources where they already exist significantly decreases transportation costs while improving mission sustainability. Scientists and engineers continue studying efficient extraction techniques that minimize energy consumption and environmental disruption. Successful lunar manufacturing would create an important stepping stone for deeper exploration throughout the solar system. Establishing productive industries on the moon could support scientific discoveries, commercial ventures, and international cooperation, while preparing humanity for future expansion beyond nearby space environments. Number 2. Asteroids. Asteroids contain enormous quantities of valuable materials that could support future manufacturing beyond Earth. Many are rich in iron, nickel, platinum group metals, carbon compounds, and water, making them attractive targets for industrial development. Instead of transporting these resources from Earth's deep gravity well, mining operations could collect and process materials directly in space. Water extracted from certain asteroids may be separated into hydrogen and oxygen, creating rocket fuel for spacecraft traveling throughout the solar system. Metals gathered from asteroids could become construction materials for satellites, habitats, and exploration vehicles built in orbit. Robotic mining systems are expected to perform most extraction activities because many asteroids have extremely weak gravity and challenging environments. Engineers continue designing autonomous equipment capable of drilling, collecting, refining, and transporting resources efficiently. Although significant technical and economic challenges remain, asteroid mining offers long-term potential for supporting sustainable space industries. Reliable access to extraterrestrial materials would reduce reliance on Earth-based supplies while enabling larger scientific missions, commercial ventures, and permanent infrastructure across the solar system in future. Number 1. Industry. A self-sustaining space industry represents the ultimate goal of manufacturing beyond Earth, where production continues using local resources with minimal dependence on supplies launched from Earth. Such an industrial network would combine orbital factories, lunar facilities, asteroid mining operations, advanced robotics, artificial intelligence, and efficient transportation systems into a connected economy operating across space. Raw materials would be extracted, processed, manufactured, assembled, repaired, and recycled within this environment, creating continuous production cycles. Spacecraft, habitats, scientific equipment, and infrastructure could all be built closer to their destinations instead of entirely on Earth. Automation would play a central role by reducing operational costs while increasing safety and efficiency in hazardous environments. Reliable manufacturing capabilities would support exploration missions lasting years, including journeys toward Mars and beyond. Sustainable industrial development would also strengthen scientific research through improved access to specialized equipment and experimental facilities. As technology advances, self-sustaining manufacturing may become the foundation for permanent human settlements, expanded commercial opportunities, and a thriving economy extending far beyond Earth's atmosphere into space. Thanks for watching and spending your time with us. We hope this exploration inspired your curiosity about humanity's future beyond Earth. Share your thoughts in the comments, and stay tuned for more exciting discoveries ahead. Thank you again, and please remember to subscribe for future videos. And subscribe today, please.